Welcome to another episode of Reimagining Cyber. This is Stan Wisseman with my co-host Rob Aragao. And Rob, we've occasionally, each of us, been a bit remote when we recorded episodes, but this time you've gone a little bit further south than normal. Where are you right now?
Well, today, Stan, my name is actually Roberto Aragao, which is Rob Aragao in Portuguese, or Robert Aragao in Portuguese. We can talk about cybersecurity if we'd like, because I am down in Brazil. And so therefore the Portuguese in me comes out. And it's all about cybersecurity all over the world. As we know, we've talked to many different guests. We need to get someone down here, actually.
While you're there, you can go and flesh out, you can try to find out who the cybersecurity experts are.
That's what I'm going to do. I'm going to go recruit and see what we can do and pull someone in. Absolutely. Yeah. Now, on to this episode, Stan. Who is going to join us today?
Well, Rob, today we're joined by Martin Roesch. Martin is a renowned cybersecurity expert and entrepreneur with over 25 years of experience. He is currently the CEO of Netography, who is leading the charge in innovative network observability and security solutions. Martin is also the creator of Snort, the widely used open source intrusion detection and prevention system. I don't know if you remember, Rob, but I certainly recall the opportunity of leveraging Snort and solutions in the past.
Absolutely.
He also founded SourceFire, which, as we both know, was pivotal in the whole advancing of IDPS. Martin, it's great to have you on the podcast. Your contributions certainly have, made you a visionary and thought leader in cybersecurity. And is there anything else you'd like to add for our listeners about your extensive background?
That was pretty good. I guess, I served for 6 years as the chief architect for the security business group at Cisco after SourceFire got acquired. But yeah, I think you hit the highlights for the most part. But great to be here. Thanks for having me. Appreciate the opportunity to speak with you guys.
Well, you got your start in network security, and you're still focusing on trying to improve it. And I want to, basically start with that whole question about visibility into what's going on in the network. So if you look at the role and importance of network security and the visibility and what's going on in the network, how do you think it's evolved over the years, especially in the context of some of the emerging technologies we've seen and increasing cyber threats?
Yeah, well, so obviously kind of the network observability thing has been my jam for most of my career. And it's pretty interesting how it has evolved and waxes and wanes to some degree, So back in the old days with Snort and SourceFire and things like that, we're essentially writing packet inspection systems, deep packet inspection systems, and putting them on the network. And, one of the funny things, so when I first started writing Snort, I was just writing it for my own needs to keep track of what's going on in my home network. And then I released it as open source and it kind of snowballed from there. But as it snowballed and as I started SourceFire and got things going at SourceFire, I became increasingly aware. So I thought, I'm a self-taught security guy, right? So back in the 90s, if you want to learn cybersecurity, you taught yourself. So I always felt like I was way behind the curve on knowledge and just
interesting
uphill battle to understand how things worked. And I always felt like there was this, this pantheon of titans out there of people who just knew what was going on. And I expected everybody just knew what their networks were doing and what was on them and all this other stuff. And as SourceFire got going, we started interfacing with more and more customers. I became kind of horrified.
Realizing that the emperor had no clothes, huh?
Nobody knew what was going on.
Yeah, that's right. No one did.
Nobody knew on their network or what I was doing. I was like, holy crap, this is bad. So we built tools to do that, and Snort was obviously a part of it. We had some other technologies we built there that do passive network mapping, looking at the packets and things like that. But you fast forward 25 years, and it's we still have the same problem. Now it's to some degree worse because you've got these hybrid multi-cloud enterprises now that are we're in AWS, we're in Azure, and we still got stuff on-prem, and and when you ask the question of what have you got and what's doing, they're like, I have no idea. I can't even tell you what's happening on the network I take care of. There are these other networks out there that I have no remit over and no ability to see into. And even if I did, the technologies that are out there for doing it, sniffer-based technologies, deep packet inspection, barely exists. The cloud doesn't want you looking at packets. You can do eBPF where you've got to do agents everywhere, or you can do, kind of some sort of cloud appliance that nobody wants because it's like, it's the old architecture kind of ported to the cloud. And then in the on-prem world, you have this problem of, as we deployed all this DPI infrastructure, you ended up with, just inspecting the ingress, egress, aka the north-south environment, not paying attention to what was going on inside the networks at all. So the problems were kind of solved approximately, whatever, call it 15, 20 years ago. And then as networks have dispersed to these multi-cloud plus hybrid enterprise models and the traffic's become more and more encrypted and things like that, it's become ever more problematic to, just fundamentally understand what you got and what it's doing. So, and that's kind of the whole premise of why I'm working again, right? SourceFire was a big success. Why the heck would I want to get back in the saddle and put every startup?
Right.
Let's kind of delve into that a little bit more because you just touched upon it, right? So DPAC inspection, it is in essence at this point in time facing that challenge of, network encryption being kind of, a way of not making it that easy any longer, right? You've alluded to some other approaches, but what would you say is the one or a couple that you're seeing be more effective at this point in time?
Well, I think people are, to encapsulate and crystallize the problems of DPAC inspection, because of the dispersed nature of networks today, and because the cloud really doesn't want you looking at packets, we're into a problem now where DPAC inspection kind of has this narrowing set of use cases because getting the sensors in the right place to look at traffic is hard. And even if you do, you've got this ramping total cost of ownership, right? TCO required to actually like inspect the packets because you got to break decryption somehow or get yourself into a topological place where traffic isn't encrypted, which is basically becoming impossible. So if you are going to attack the problem in this world, you need to really rethink what you're doing and kind of what's important to people. And to some degree, when I started developing 25 years ago, I didn't really ask people what they needed. I built what I thought was right, and then people kind of said, "Ooh, I like this. Could you add that, or could you change that?" and stuff like that. So, I'm kind of the, if people ask me what, or if I ask people what they wanted, it was a faster horse, Henry Ford quote kind of guy. So you have to have opinions, and you have to like form them, and then kind of bring them forth, and then start iterating on them and riffing on them as you expose them to the people that are out there. So, so to me, as I started looking at, and actually quite a long time ago, over a decade ago, what was going to happen to DPI-based solutions if all these trends of encryption and dispersion and the ephemeral nature of things in the cloud, let's not forget that, continued. How are you going to do this? And the approaches that made sense to me, especially at the network layer, was essentially you're going to have to start operating off of metadata. You're going to have to start taking the information about what's happening in the environment, not trying to inspect the things as they were happening on the wire. Because if you went to a metadata approach, you can start leveraging all the infrastructure that's there that all these multi-cloud plus hybrid environments are built on, which means you're going to have a very different deployment modality, but you're also going to have the ability to start seeing again at scale across everything without having to have these kind of Byzantine / bespoke sensor architectures that are only inspecting very small segments of the environment for very specific things. Your ability to really have observability changes when you go to this kind of model where you're letting the environment tell you about itself, kind of like we did 20 years ago, but you're using very different data types to make it happen.
We'll dive into the metadata aspect in a second, Martin, but if you look at what the service providers, the CSPs are providing, a lot of them are providing log analysis kind of services, right? Or access to the logs. And, again, not being able to necessarily do DPI anymore in these cloud environments, especially multi-cloud, right? But log analysis being an alternative service they're offering. Do you see that as less effective, or perhaps not getting you that real-time perspective on what's going on?
Yeah, well, it's always been a triad, right? The network, the logs, and the host / endpoint, right? And as we move to the cloud, and this is kind of a quip I had to my friends probably 10, 15 years ago, as things were starting to evolve this way, I started to look at, oh, they're encrypting all the traffic, and oh, they're moving to the cloud, and the cloud doesn't want you sniffing and stuff like that. And I said, boy, these trends that are happening right now, if you believe this is the way the security is going, then you better love endpoint defense and log analysis, because that's basically all you have unless you come up with a new network.
And look what happened.
Yeah.
Right. So do I think it's enough? Well, it's good, but it's not great. I mean, you're essentially, especially in the case of compromise, you're depending on the reporting system, on self-reporting from the system that's been compromised in many cases to say, hey, I got hacked. And of course, the attackers know this, and they're going to do to make sure that doesn't happen. So you've got that problem, and you've got it's somewhat mitigated by running workloads on VPCs and things like that, where you have the ability to kind of be outside the machine. But you're still, in many cases, all this data gets shipped off to a data lake, and you're operating on very different timescales than we've been able to operate on at network speeds when we're looking at things in real time and near real time. When we're talking, in the case of the old technologies, microseconds, seeing things as they happen, to maybe a couple of minutes. And typically in these data lake models, you've got dashboarding and reporting, and you really don't have a whole lot else. So you've got things kind of grinding away in the background, and it could take hours to get a notification that, hey, something fishy is going on. You might want to look into that. So, I think, a lot of money has been spent on app security. A lot of money has been spent on building these massive data lake environments in the cloud and stuff like that. But to date, nobody's really come up with an architecture that's appropriate for working across these networks that we have today, and providing that third leg of the triad that we've had really for all of security history up until very recently.
So you kind of talked about this as well a little earlier. I want to delve into it a bit deeper, which is the metadata aspects of it, and leveraging that, to help really kind of get more of an understanding. Because listen, when I look at it, the metadata is going to give you kind of just said it too, right? It's going to say, hey, something's happening here, right? There's been a compromise. But like, where does it get into the depth of understanding of what's really occurring, one, and two, how does it help kind of shape the response strategies, the changes that need to happen, in essence, the response strategies going forward? Like, what perspective do you see in the metadata aspects playing a role to make things that much better, if you will?
Yeah, well, it's interesting. So to some degree, the first step to getting better is just admitting you've got a problem, right? We've all heard that before. And I think one of the things that we as an industry maybe need to have some introspection about, let's just put it that way, and I am one of the people who's responsible for the state of things as they are today, I will admit that, is that 25 years of threat detection has given us 25 years of largely vast piles of false positives that, you apply massive amounts of people and process and technology, aka money.
It can be noisy, right? It can be noisy. Yeah.
Right. To figuring out kind of what's going on. And at the end of the day, I get an indication that essentially, I've got a compromise here. I need to kick off my IR playbook. So when you go to a metadata approach, what you're not going to be doing is detecting the threats the way that we have before. So you're not going to say, I just saw a log4j attack. Now, you kind of have to ask a question. Okay, if I knew that was a log4j attack, would it change my response if I had other mechanisms telling me that, hey, this thing is, all of a sudden changing its behaviors, it's doing things that it hasn't done before, it's, turned into a port scanner or whatever, this printer just started scanning the network, things like that. And, if the answer is probably not really, right? Because I go from vast pile of events through this people process technology pipeline to here's an incident that gets me to kick off my IR playbook. So part of the thesis here is, why do I have to do all of that? The time delta between when I'm going to have an initial determination that something's up and when I'm actually going to do something about it is typically measured in, at least hours. So my detection timeline, like horizon threshold, the microsecond that it happens or, a minute later, for most organizations isn't going to have a massive amount of impact. And we can do so many more interesting things when we start looking at detecting the compromises instead of just saying, I just saw 10,000 threats. Here they are. Have a nice day. Because now I can start asking and answering questions like, like why did Marty's laptop ship 20 gigs of data to a vending machine in the break room? That's something we really need to dig into here. And you're never going to do that with a threat-based system because threat-based systems aren't going to be set up in a way that allows you to even ask that question. Hey, am I seeing anybody doing anomalous transfers of data between, management network and, anything that's, not these functional areas of the environment? You can ask that question when you start doing metadata-based analysis, when you can start building business logic based rules in addition to kind of intrinsic technical logic based rules. So it really kind of changes the game of how you can do things. And I think that's very important, especially in today's networks that are so dispersed, because you just can't get that kind of coverage DPI based systems or even agent based systems, just because of the nature of both of them.
And in fact, you've written about some of this complexity, especially, and again, this hybrid or multi-cloud environment, and that volume of attack data could be overwhelming to a SOC, and again, not being able to act effectively or any differently than if you just knew there was a compromise on a particular asset within an environment, right?
Mm-hmm.
And so, can you speak to this challenge of again needing to have that coherent kind of perspective across cloud environments to be able to apply security effectively, and then also be able to respond effectively to those? And perhaps that metadata approach is part of that answer.
Yeah. So one of the problems that we're having kind of industry-wide, I would say, is that the security for the different kind of functional areas of our environments is very siloed. So this should not surprise anybody that I'm saying this, right? So in the on-prem IT world, I've got one set of solutions. In the AWS world, I've got a different set of solutions, and yet another one in the Azure world. And, I'll probably have a different technology in the OT environment as well. So, this way lies madness, obviously. We're just going to staff all of these tools, maybe with the same people, maybe not. Everybody's got to be trained up on all these disparate technologies. They've got to get their data back to some place where they can kind of share what they're seeing. That has to be interpreted and turned into analysis and response and so on and so forth. And it's very complicated, right? So, the old tropes, right? Complexity is the enemy of security. If I'm trying to deliver the same capabilities across all these environments, why would I want to do that with different tools? If I had one thing that could do it all? And, the answer, obviously, and this is self-serving, I know, is that there are ways you can do that, but you need to rethink how you're attacking the problem. And that's essentially what I've been doing for the last several years in my day job. And it's that's what Netography was built around, was this whole idea, hey, there's a different architecture for doing this in this world, and you can actually build a unified experience and things like that. And I think it's impactful because all of those different pieces add friction to the problem space, right? So if I've got a cloud ops team and I've got a security ops team and I've got an OT ops team, let's just call it, and they're all different teams, they're all trained on different tools, like that is so much friction you're adding. And anytime something goes off the rails, like, the IT guys see something fishy in the OT environment, but the OT guys didn't pick it up. Now you've got, this kind of built-in systemic friction. What do you mean we didn't see it? We paid real close attention.
One of the other things that'd be interesting to kind of get your perspective on is looking at, these complexities in essence that we've been discussing around these multi-cloud environments. And again, that evolution of, a customer of ours, for example, may have started working with Azure, Martin, and then they kind of say, okay, these other things that we need to accomplish, and we think that our costs, our capabilities for that particular use case or set of use cases are better to go back to maybe an AWS or a GCP. You pick it. And so they get this hodgepodge now of, cloud service providers that they're having to work with. It becomes difficult. For incident response is another example of that. And especially when you think about kind of this lateral movement, opportunities the attackers now have going across these different cloud environments. I guess, do you have any thoughts and maybe best practices that you could share with the audience on how to help deal with that?
Yeah, well, I think, interestingly enough, I think, and this is, this is the product of a lot of thinking about it, but also, we're trying to do something about it in Netography. I think lateral motion has become one of the most interesting and underserved problems in security right now. And the reason that I say that is if you look at most of the defenses that are out there, they're either not in real time, or they're not looking at the right things, or, they're only looking at north-south traffic, or they're only looking at the workload level of what's going on, and so on and so forth. So that seeing lateral motion, especially cross-cloud lateral motion, is virtually impossible, especially in kind of relevant timescales. If you're doing an incident response, you can dig through all the data and then synthesize where I saw this at GCP and then I saw this at AWS. Oh, those are the same thing. That's, problematic. That whole motion of trying to do that, there's, it's hugely complicated and there's high friction between making that determination because once again, the tools aren't there. And this is one of the things that I think has really been interesting about this kind of journey that I've been on is that, we've been building out the cloud for, call it 15 plus years. And there's great AppSec tools. There's great, CSPM, and there's, the native tools and stuff like that are okay. They're the basic job done and things like that. But we've got, all the AppSec stuff. We got the CNAPs and the CDP, all the C's, CDP, CWPP. But nothing looking at the network layer. And because of that, you have really low ability to kind of intuit or simply answer questions. Has there been lateral motion between point A and point B, both in the multi-cloud world as well as in the on-prem world? And I think it's really fascinating because in the zero trust environments that we're trying to build now, zero trust is kind of like the kind of fundamental assumption that most people have. Zero trust is all about containing the blast radius, right? So they can break in, but they can't get out because the identity and access management system won't grant them access to get to anything else. The attackers know this. It's the first thing they go after when they get into a place.
And that whole escalation of privilege is part of the game plan, right?
Exactly. That's the absolute first thing they're going to do. And when they break containment, what have you got that can see it? If you're not instrumenting the east-west environment in the network, the lateral motion environment in the network, your barriers to entry to observe this activity goes very high, very quickly. And the other problem with doing it, and this is why we never did it in the DPI days, is because if you're doing it packet-based, it's impossible to scale.
Well, especially with appliances, right? I mean, if you had the appliance model that you had back then.
Or really any sensor infrastructure. So, a little inside baseball. We have, a large organization who's looking at instrumenting their entire east-west environment with us. And they have tens of thousands of switches across, and this is their on-prem environment, it's not cloud, tens of thousands of switches, right? Tens of thousands of points of monitoring. If you really want to see the east-west traffic, cross-switch traffic, that's where you got to be. And there's nobody has that. There's not that much money on the planet to do that unless you do an approach where you're leveraging metadata.
So one of the things that's happened in the last month is, we've had a major breach associated with a cloud service provider, Snowflake, right? And granted, the avenue of attack was through an account that was, perhaps they had poor identity governance in this context, but it wasn't necessarily a weakness per se in the Snowflake controls, but they were able to escalate and able to take advantage of and get access to a lot of information. Do you think that the network level detection capabilities you're talking about would have helped in that incident response?
It wouldn't have hurt.
I mean, again, part of that is trying to figure out that lateral movement, right?
Yeah, visibility and observability are kind of, they're a bit of a journey on the one hand, but on the other hand, if you've got the infrastructure there, it's very simple to ask and answer the question of, hey, man, this happened. What do we see surrounding that? What's happened at a network level? And if you didn't have the infrastructure there in the first place to collect that information and be able to provide the insights and things like that, then you're just, you're kind of back to looking at log file.
The corollary I think of is on the software side is, again, the context of SBOMs, right? You're trying to get visibility as what software is running in your environment. So if you have a Log4j and you want to know what other apps are exposed because of using this particular library, then you can actually respond to it more effectively. So at each layer, you sort of need to have that visibility into what's going on to be able to react more effectively.
Yeah, absolutely. And it's extremely important. If you don't have it, you're effectively, in many cases, just flying blind, right? You're just depending on app logs and system logs and things like that. So you've got to be able to kind of put the pieces together and follow the breadcrumbs as opposed to, hey, man, this thing got compromised. Show me everything as it's talked to in the last 2 weeks, and being able to get that footprint and then start chasing down, okay, what does it usually talk to? Because you ask and answer that question. And then, okay, one of these things is not like the other, which one is it? And then kind of start digging from there. So, and the tools that you need to do that, especially if you want to be able to do, really high speed incident response. And I shouldn't make fun of data lakes because they do provide a lot of value, but especially if you're looking at a network level, this is one of the things that we've done very specifically is not build a data lake, but build a data store that's set up specifically for the data types that we're dealing with. So instead of, asking a question to the back end and getting an answer back in, hours plus, you get an answer back in, a few seconds. And that allows you to start pivoting through the data, right? It's not, we're operating on human brain time scales where, oh, okay, I saw that, click, pivot, click, pivot, click, pivot, and, build a picture, or you have the analytics tools to show graphically represent what's going on and show it not just in terms of this box talk to that box, but show it like geographically, like, oh man, that box was in, Peru. We don't have any assets in Peru. What's going on here?
So here's a question I ask every now and then at the end of an episode, Martin. I think I know the answer that you're going to give, but I'm going to ask it. Look into that crystal ball. And as you do, and we think about multi-cloud security that we've been talking about and the problems and challenges that are out there, what do you believe the key emerging threats are going to be out there, and technologies really support those identification of those threats will center around? What's the anchor point? Where does, that take us at this point in time going further to be very specific against the multi-cloud kind of environment aspects we've been discussing?
Yeah, well, I think to some degree, this whole concept of identity as a perimeter or as the perimeter has kind of gotten its exposure to the actual battlefield and been shown to be kind of like nice theory, but doesn't actually work in application the way that we hoped it would. I think there's really interesting work going on in data security right now, actually. And I think that will be helpful for sure. But I think that especially in these multi-cloud environments, having unified tool sets that can operate kind of equivalently across all the different cloud environments or as equivalently as possible is going to be very, very important because you're going to use different cloud environments for different things. Maybe you run your apps at AWS and you're doing your enterprise stuff in
Depends on the use case, right? I mean, depends on what's optimal.
Like almost every enterprise is going multi-cloud, and you'd be a fool not to, right? You want to have some leverage against your AWS build, for example.
Right.
So that being the case, like removing friction from the system is really kind of fascinating because we talk about frictionless platforms and frictionless software and all these other things, and it's important, right? And we talk about it ourselves. Our stuff's frictionless. We have nothing, no agents, no hardware. Great, cool. But removing friction from security, like especially in multi-cloud environments, being able to like actively remove friction between your operational elements of your organization, as well as remove friction between the deployability and the scaling, and being able to ask and answer questions from the systems that you deploy and things like that. It's going to become critically important because the scale of these networks is increasing so rapidly, whether they're multi-cloud or multi-cloud hybrid with, plus on-prem. The scale of these networks is growing so rapidly, and your kind of quote unquote location, your footprint in on the internet is so fungible now that you have to have low friction architectures for security that can follow the problem, follow the enterprise, follow where the capabilities are needed when they're needed. Because if you don't have something like that, if you have old school sensor architectures where I got to roll out this, this appliance image in this cloud to get my, do my compliance checkbox and stuff like that. I mean, that is like it's super 20th century thinking. You've got to be able to move at the speed of the cloud. You've got to be able to move at the speed of the customers. And the only way to do that is to be as frictionless as possible, not just the deployability of the system, but reducing friction across kind of the operational domains that the system provides its capability and utility within. So I think that's really going to be where you're going to see the biggest and probably most interesting opportunities is companies that can deliver unified multi-cloud capabilities that scale to any size and that are as frictionless as possible. And that's obviously what we're doing from our vantage point of rebuilding the third leg of the triad of, network security essentially for the multi-cloud world.
Well, Martin, appreciate you coming on and kind of shining that light on something. Honestly, in some cases, I think people aren't really paying attention to any longer, the network piece and the reasons why it's important, but also the approaches that one should be considering and taking to help solve for that problem. So really appreciate it. Great to have you on. Look forward to maybe talking to you again in the future.
Excellent. Thanks for having me, guys. I really appreciate it.
Hey, thanks, man.
Hello, producer Ben here, and if you've been listening to Rob and Stan talking to Martin Roesch and fancy some more cloud-based podcast action, then fear not, Reimagining Cyber has got you covered. Episode 34 featured Jim Reavis, co-founder and CEO of the Cloud Security Alliance and a noted leader within the cloud computing community. It was called Solving the Cloud Security Puzzle.
All of the questions about how you handle the data, the decisions you make, are you going to do multi-factor authentication, all those things, that's what it's really important to understand. And so typical large company, maybe they're working with 3 big infrastructure providers, and they probably have 2 to 10,000 applications, SaaS applications. That's where they've got to be continually looking at at a high level, the security of those SaaS applications. And for the infrastructure stuff they're building, they have to build in almost all of the securities.
That was Jim Reavis, who you'll find speaking to Rob and Stan on episode 34, Solving the Cloud Security Puzzle. Finally, whatever you're doing right now, maybe you're on your way to work, at the gym or walking the dog, why not pause for just 1 second to follow, subscribe and share the podcast. I promise that it will give you a warm glow inside. Thanks for listening and goodbye.